El webinar del día de hoy es el camino a la transformación digital de la mano de FEMIA, impartido por Dave Todd, líder global de estrategia de la industria aeroespacial y defensa de Siemens. Le agradecemos mucho a Dale y también les informamos que la próxima semana tendremos en nuestra serie de webinars de la FEMIA el webinar Sistemas de Observación de la Tierra, Nuevas Tecnologías y Aplicaciones a cargo de Benjamín Ajar, que es el CEO de Thrusters Unlimited, que y, por cierto también está a cargo del tema de la Comisión Aeroespacial, participa en la Comisión Espacial, perdón, de la FEMIA. Si gustan, ahí está el código QR para que puedan hacer su registro desde ya. Y este webinar será el miércoles 4 de agosto a las 11:30 de la mañana, tiempo del Centro de México. Bueno, platicar un poco acerca de FEMIA. Somos una asociación civil sin fines de lucro privada que fue fundada en 2007 y que cuenta con las principales empresas de la industria aeroespacial en México en los temas de manufactura, mantenimiento, diseño, ingeniería y otros servicios. Contamos con alrededor de 120 miembros y más del 80% de las exportaciones aeroespaciales del país son hechas por miembros de FEMIA, ¿verdad? El origen del capital de nuestros miembros es aproximadamente 35% de México y 65% extranjeras, aunque debo decir que el porcentaje de México ha ido creciendo como tendencia en los últimos años y esperamos que esto vaya también a la alza. Colaboramos, tenemos un enfoque nacional y colaboramos con organismos afines a nivel nacional e internacional. Tenemos algunos de nuestros miembros, van a poder reconocer algunos logotipos de algunas compañías conocidas. Los que no son a lo mejor tan conocidas son igual de importantes porque todos forman el ecosistema de la industria aeroespacial nacional. Bueno, aprovechar la oportunidad para presentarles al equipo de trabajo que comanda René Espinosa, que es el presidente del Consejo Directivo. Tenemos a Pamela Arellano, que es la directora de operación, Mónica Vega, directora de promoción de atracción de inversiones, y Javier Hurtado, que es el director de desarrollo de proveedores. Está Mariana González, gerente de gestión y membresía, Marta Ortuño, asistente de dirección y administración del proyecto, y Enrique Maldonado, también gerente de proveeduría, su servidor, Luis Gerardo Lizcano, presidente ejecutivo de la asociación. Bueno, también aprovechar la oportunidad para extenderles una invitación muy, muy calurosa a lo que es la gran fiesta de la industria aeroespacial nacional hacia el mundo, FAMEX 2021, que se llevará a cabo del 22 al 25 de septiembre en el Aeropuerto Internacional de Querétaro, con la participación de Estados Unidos como país invitado de honor. Va a ser un gran evento y esperamos verlos allá todos. Reserven su espacio, no dejen de participar, es muy importante que estén en esta gran reunión. Bueno, también informarles que al final de la presentación de nuestro invitado del día de hoy, de la presentación de él, tendremos una sesión de preguntas y respuestas. También debo decirles que la presentación de Dale será en inglés, entonces para que pongan atención y saquen sus habilidades para entender y hablar inglés. Bueno, aprovechar ahorita también para presentar una leve semblanza de Dale Todd. Es el líder global de estrategia de la industria aeroespacial y defensa para Siemens. Tiene más de 30 años de experiencia en ingeniería de diseño, desarrollo y lanzamiento de programas en la industria aeroespacial en Estados Unidos. Y antes de colaborar con Siemens, Dale ha acumulado una experiencia muy vasta en puestos estratégicos en compañías como Bombardier Aerospace, The Space Ship Company, programas militares del gobierno de Estados Unidos, Cessna Aircraft Company, entre otras. Y bueno, para que nos ayude a presentar adecuadamente a Dale, le voy a pedir a Ricardo Rodríguez de Siemens, que le voy a pasar la palabra a él para que prepare la presentación y nos presente a nuestro invitado del día de hoy, Dale Todd. Ricardo, adelante. Muchas gracias y gracias por por su colaboración.
Muchas gracias, Luis. Claro que sí. Es un gusto, bueno, poder estar aquí con ustedes en esta sesión. Como bien lo mencionaba Luis, mi nombre es Ricardo Rodríguez y quiero dar nada más una breve introducción, sobre todo para ver el contexto del programa que estamos desarrollando en conjunto de FEMIA y pues de dónde sale, digamos, la plática que vamos a tener en unos momentos más, bueno, que mi compañero Dale también nos va a apoyar a impartirla. Bueno, mi nombre es Ricardo, yo soy también parte del equipo de Siemens Industria Software, de todo lo que es la región de México y Centroamérica. Y parte de mi objetivo, junto con otros compañeros, es poder acelerar esta transformación digital que hemos estado viendo a mejor en otros sectores, en otras industrias, y bueno, que el sector aeroespacial no se queda atrás. Entonces, hemos visto, sobre todo en el sector aeroespacial, que es un sector muy noble en el cual nos ayuda como país a desarrollar tecnología, a generar obviamente innovación de procesos, innovación de materiales, pero que ahorita lo que hemos estado viendo es que si no pensamos en un tema de transformación digital dentro de nuestras compañías, pues realmente va a ser un poco, digamos, no difícil, pero sí retador poder afrontar estas, pues apostarle a este tema de innovación y poder implementar nuevos procesos de manufactura. Entonces, el objetivo es pensar y cambiar hacer esa transferencia de temas de transformación digital para nuestras organizaciones. Nada más un dato muy particular y también para saber en dónde nace todo este contexto, hay datos y hemos visto encuestas de que cerca del 87%, por ejemplo, de los encuestados que se tuvo a nivel global, piensan que la digitalización va a ser algo fundamental y que puede llegar a afectar parte de la industria y como bien mencionó, lo que es el sector aeroespacial no se queda atrás. Sin embargo, lo que también hemos detectado es que muy pocas, casi la mitad del porcentaje de estos encuestados dentro de estas empresas han hecho algo para poder afrontar estos retos, ¿no? Estos cambios de temas tecnológicos y poder abrazar, pues vaya, la digitalización dentro de sus organizaciones. También, obviamente, la pandemia hemos detectado eso con otros sectores en los cuales, bueno, si apostaron en temas de digitalización previo a la pandemia, creo que han tenido menos efecto, menos rezagos a través de esto, sobre todo el año 2020 y lo que llevamos de este año. Entonces, junto con esto, con estos términos y con estos números, junto con la FEMIA, generamos un programa de desarrollo con el objetivo de acelerar la transformación digital del sector aeroespacial en México. Entonces es un programa continuo, es un ciclo continuo que estamos generando y justo el día de hoy, digamos que el primer actividad es la sesión que vamos a tener hoy y que nos va a apoyar Dale para que podamos presentarlo. Prácticamente son la primera actividad va a consistir en platicarnos un poco cuáles son los retos, cuáles son las tendencias del sector aeroespacial, hacia dónde se está moviendo esta industria y pues, dónde estaríamos pudiendo pensar que podemos nosotros implementar esta tecnología dentro de nuestra organización. Posteriormente, la sesión de hoy también va a ser nuestro segundo paso, poder tener junto con ustedes una sesión virtual donde nosotros les ayudaríamos en conjunto con nuestros expertos de Siemens a hacer un diagnóstico de madurez digital de sus organizaciones. Si bien a lo mejor hay algunos de ustedes que ya están haciendo algo y hay iniciativas dentro de la organización y aquellos que todavía no, creo que esta actividad que vamos a hacer, que es una actividad virtual, nos va a dar mucho beneficio, donde prácticamente, bueno, vamos a tener sesiones y creo que voy a platicar un poquito más de este tema más adelante, pero esta madurez digital nos va a dar una radiografía de dónde nos encontramos con respecto a la industria y poder revisar esos gaps de dónde, pues vaya, dónde me va a tomar más esfuerzo y poder alinear y priorizar de acuerdo a las iniciativas de la compañía y de acuerdo a donde yo quiero ir o el camino que debo de seguir. Posteriormente, para también ayudar a ustedes, bueno, hay nuevas tecnologías, hay nuevos desarrollos tecnológicos que también quisiéramos que ustedes los conocieran más. Estamos generando un tipo de masterclass o asesorías en en las cuales nos vamos a poder conectar con ustedes para explicarles más el funcionamiento de tecnologías que habilitan lo que son el desarrollo tecnológico, y posteriormente vamos a tener lo que viene siendo una sesión que es limitada. Digamos, todas las sesiones pasadas vamos a hacerlas poder invitar a N cantidad de compañías, pero esta sesión, que es la cuarta sesión, que es el generar un mapa, la ruta por la cual debemos de seguir, es una sesión que le dedicamos más días. También es una sesión gratuita, pero que está limitada por el tiempo que podemos dedicarle nosotros a sus organizaciones. Aquí vamos a tener un assessment un poco más detallado con los líderes de ciertas áreas dentro de su compañía para poderlos acercar, poder saber cuáles son sus iniciativas como compañía, a analizar lo que tuvimos, por ejemplo, en el tema del assessment del TMA, que nosotros llamamos el Digital Maturity Assessment, y poder empatar esas iniciativas de compañía con lo que obtuvimos de ese análisis para poder definir la ruta que vayamos a seguir. Y posteriormente poder definir un plan de actividades para poder implementar cierta tecnología habilitadora para ese tema de transformación digital. Entonces, eso es prácticamente la segunda actividad que les comentaba, la parte de Digital Maturity Assessment. Esa es un assessment que vamos a ver de diferentes áreas dentro de cada organización. Está orientada a que líderes de cada una de las áreas de ingeniería de producto, de ingeniería de manufactura, de calidad, cadena de suministro, producción, todo lo que involucra a una compañía estén dentro de esta actividad que les comento, es virtual. La próxima la haríamos el 19 de agosto para que podamos participar y que puedan ustedes participar. Vamos a poner más adelante el link de registro para que puedan entrar. Es una sesión virtual de 2 horas, donde vamos a ir haciendo cuestionamientos sobre todo estas iniciativas de digitalización de la industria aeroespacial. Entonces, de ahí ustedes van a poder obtener, por ejemplo, lo que mencionaba, estos resultados. O sea, tener esta gráfica de radar, donde ustedes van a poder observar dónde se encuentra la industria, el sector, y dónde están ustedes para identificar esos gaps que a lo mejor nos hace falta darle foco, meter a lo mejor a alguna iniciativa interna para poder desarrollarla. Entonces, ese tipo de resultados ustedes los van a obtener a través de esta actividad. Y con las masterclass que les mencionaba, vamos a conocer más estas tecnologías habilitadoras. Son sesiones virtuales muy cortas que vamos a estar pudiendo generar. Pues ustedes van a poder estar entrando para conocimiento, para asesoramiento, para poder entender más cuáles son estas tecnologías y pues saber en dónde podría aplicar más dentro de nuestra organización. Lo que mencionaba de este Value Map son estas sesiones que todavía no hemos definido una fecha, es de acuerdo a lo que ustedes nos piden, nos soliciten, y como les mencionaba, es un equipo, un espacio limitado, donde ahí vamos a estar junto con expertos de Siemens, los líderes de cada área y parte de su grupo de cada área, para que nos comenten, oye, ¿cómo hacen ustedes las actividades al día de hoy? ¿Cuál es su proceso que siguen? En base a nosotros mencionamos cuál es el proceso que siguen las empresas de clase mundial en términos de digitalización a través de todas esas iniciativas, y a evaluar, ¿no? Poder todavía pulir un poco más lo que tuvimos del resultado del Digital Maturity Assessment para poder definir lo que viene siendo una ruta. Prácticamente esto es como algo, un resultado, ¿no? El nivel de digitalización, poder definir por fases de acuerdo al impacto que tiene dentro de la compañía, y sobre todo lo más importante es que está alineado a los objetivos de cada uno de ustedes. Como les menciono, este es individual, no lo podemos hacer general. Cada compañía es diferente, cada compañía tiene diferentes procesos, diferentes visiones. Entonces, esto se alinea a cada una de ellas. Entonces, es una actividad que vamos a estar generando. Entonces, todo este programa lo pensamos en eso. Es una manera de acelerar esta transformación digital de las empresas aquí en México, del sector aeroespacial, y conjunto con FEMIA es lo que estamos haciendo. El primer paso ya lo estamos dando, es asistir a esta sesión que estamos teniendo y que vamos a apoyar a presentar más todo el panorama, hacer un overview de lo que está pasando en la industria en el sector aeroespacial, y con ustedes, pues bueno, continuar con los demás pasos, ¿no? Siguiente, que sería tener este assessment virtual. Es muy dinámico, 2 horas donde ustedes van a tener una radiografía. Los invitamos a que puedan participar. Y este es como el timeline del proyecto. Como menciono, es un proyecto a 1 año. que es continuo, donde vamos a estar definiendo y puliendo, y es un ciclo cerrado que nos va a permitir estar haciendo ese análisis cada año para también saber si la visión sigue siendo la misma, si las iniciativas se están implementando correctamente y los beneficios que están obteniendo dentro de nuestra compañía son los adecuados. Pues más o menos son este tipo de roadmap que podemos generar. Y el día de hoy prácticamente damos ese primer paso, como les comentaba. La primera sesión, que en este caso mi compañero nos va a presentar, que es posible dentro del sector aeroespacial a través de la digitalización. Entonces, ese es un breve resumen del programa. Vamos a dar va a poner los que son los links de registro para la siguiente sesión, posterior a la presentación de él. Entonces, sin más, por el momento quiero cederle la palabra a Adel. Cualquier duda del programa, cualquier duda de información, está en el chat, pueden hacernos y al final podemos responderlas también dentro de la sesión de preguntas y respuestas. Entonces, vamos a cambiar a switchar a inglés. I want to switch to English there. Thanks for joining us to this webinar. And well, I think that you can share your screen and start your presentation, and thanks for joining us.
All right. Thank you very much. I appreciate being here, and let me get my screen sharing going here, and there we go. All right. Well, thank you very much for everybody that's joining today, and I'm looking forward to sharing this information with you and having a bit of a follow-up discussions afterwards. So, we are in such exciting times within aerospace and defense industry. I mean, even with the challenges of the pandemic right now, it's just amazing amount of innovation that we have going on, and what different companies are doing and what our different customers are doing. Whether it's electric aircraft, such as what Aeroespacial is doing, that will support a lower cost training for new pilots, but also will really contribute to a much more sustainable future as we go forward. Companies like Rocket Lab that are bringing new innovations to launching satellites into space. And when you think about this, space used to be the domain of big companies and big governments, but now it's the domain of a lot of smaller companies as well. Startup companies, it wasn't that long ago that we talked about SpaceX as a startup company. Now they're a major player. But companies like Virgin Galactic and Blue Origin that recently Sir Richard Branson and Jeff Bezos both went to space on their respective companies. I mean, I don't know. 10 years ago, who would have thought such a thing would happen? So it's very exciting. A lot of disruption in the industry. We're even seeing this disruption in the defense industry. If you think about the trajectory that a lot of these programs have been on, the cost just keeps going up, and now you have new programs that are starting around the world. This is an example from the United Kingdom with their Tempest program, but we're seeing in the US, Russia, India, Japan, countries all over the world are starting new fighter programs. They're looking for the next generation of capability, but they're looking at 50% of the cost and schedule of the previous generation aircraft. They're not looking to bend the cost curve. They're looking to break it. And so this really presents a lot of opportunities for companies, and there's a lot of digital emphasis as they go forward. So within all of this innovation, this disruption, to really be able to survive and thrive in this age, this new age, the digital era, companies really need to become digital enterprises themselves. They need to rethink all of their processes and how can they change themselves with digital. To have business transformation, you have to have digital transformation. As we look around the world and all the different companies that we work with, we're seeing some common trends. You're seeing this pressure to reduce your program cost and schedule, to get to market faster than than your competitors, and to be able to drive efficiencies into all your manufacturing processes and your supply chain so that you can produce a lower cost product for your customers faster. We see the programs themselves, the products becoming much more complex. There's more software in them. They're using more integrated systems to try to reduce weight of their airplanes. But the products are becoming more complicated, and this affects how you engineer the product, but also how you manufacture the product. Increasing electrification continues. And it's not just about using electric propulsion in terms of sustainability, but it's also about just electrifying the systems on the airplane so that you're replacing, a mechanical system such as a hydraulic systems with electromechanical systems to get more reliability and make it easier to maintain. And then finally, globalization, whether we see it in the supply chain or the workforce, we're seeing that there's a stronger need to be able to collaborate effectively and have transparency across the globe with respect to how you engineer and build your products. And maybe at some level, this has been made worse by the pandemic, where more and more people are now working from home. So you're having to collaborate with people no matter where they are in the world. With all of this complexity, we're just, we see these products getting more and more complex. We see the business relationships becoming more and more complex. And what some companies are doing in this explosion of complexity is they're trying to simplify. They're trying to manage the complexity, but to reduce our costs and the risk. But what we're actually seeing is the companies that embrace the complexity, that embrace digitalization to help manage that complexity, that they are actually producing higher performing products at less cost and faster. And so by embracing this complexity and using digital transformation to embrace this complexity, we're seeing companies having great success. And I'll share some examples of that as we go. What these companies are doing and what they're using to gain a competitive advantage is, first, they have a comprehensive digital twin. They have this rich, robust understanding of how their product operates, as well as how they're going to build it and then support it. They're using personalized, adaptable, modern solutions that are configurable, that are easy to deploy. We're seeing all of our customers moving away from customized solutions into more configurable solutions so that they can keep up to date with the latest technology. And then finally, we're seeing the most successful companies using a very flexible and open ecosystem. You have legacy solutions that have worked for you for a long time, and you need to be able to continue to use those so that you can maintain that competitive advantage. But you also have to be able to bring new systems on, new technology online, and you can only do that when you're in a truly flexible and open ecosystem. And so this, by far, to me, is the key to really being able to go faster, is to really truly operate where you can be in an open ecosystem when you can use different applications as you go forward in your programs. So why is the digital twin important? Well, when you have this rich, robust understanding of your product, you can have faster time to market. It enables you to reduce the amount of testing. I'll talk about that a little bit, but it also enables you to build your products faster. You drive innovation because you're able to look at so many different designs, configurations, plant layouts. You go faster, you look at more options, and you maybe get a chance to look at something that you wouldn't have looked at and seen in the past. So you gain insight because you have this digital twin and that you can automate some of these tasks. You're able to extract value from these mountains of data. And when you, especially once your products are operating or if your production line is operating, you're able to use the digital twin to actually make sense out of all this data that you're collecting, and then use that to optimize those processes. This helps break down those barriers between all the different disciplines. It breaks down those silos. It helps unite these disciplines because you're able to have transparency across your entire product development and manufacturing lifecycle. You're able to anticipate be more proactive because you have that data, because you're using the digital twin to help gain insights from that data. And then finally, and what we're seeing with a lot of companies is they're just delivering new business models around the digital world by enabling digital through all of their processes. When we talk about what is the comprehensive digital twin, it starts with your product, which you have the virtual product, which is the representation in the virtual world of your physical product. So it's your 3D models, it's your analysis, it's your bill of materials, it's all of the information required to produce the product. You then transition into virtual production, where you're looking at your assembly lines and how you will set up your assembly lines, your manufacturing facilities, and then you can virtually commission that assembly line in the digital world. And then you move into real production, where you're leveraging the insights from the digital twin to help increase your automation in your real production processes, and then you deliver your real product. And the value of the digital twin, as I said on the previous slide, is you now start to take these insights from your production and your real product's performance, and you're using those to optimize your product and your production design. And you're able to get and drive continuous improvement into your existing processes. But the real benefit of this is, and as you use these insights to optimize your current production facilities or your current design, product designs, is the next time that you start, the next program you start, or the next assembly line you start, you're able to actually leverage this information from the previous program that's been validated against actual performance and use that as a starting point to achieve higher performance on the next project. And it just continues to grow and build on itself. And so it's a really great opportunity for you to be able to have continuous improvement, not just across the product, the product life cycle of one product, but to help you continue to make advances on the next product. And within the accelerator portfolio, we also have what we call these digital threads and these industry solutions that help generate program execution excellence, to help you design new products faster, but to also help you manufacture and support them better. And so what we see is we've divided these into five different functional areas of any major project. So engineering with model-based systems engineering, product design, verification, but then also program management, supply chain, manufacturing with production, and then finally with product support, we have a digital thread around that as well. So these five functional areas are covered by these 7 digital threads. So the previous slide might imply that these are serial activities, but in reality, they support the entire product lifecycle. So when you think about a generic product lifecycle like we have up here, moving from conceptual design through your design and testing into production, these digital threads cover the entire product development lifecycle. And if you think about these digital threads for these functional areas as horizontal, and then you really have a lot of vertical interconnections, so you end up with an intertwined, interleaved fabric of digital threads that gives you great transparency and great visibility throughout the program. So what does that look like in practice? We have we start with the foundation of your data and your process foundation to be able to manage and orchestrate your engineering data, all the digital twin data, your processes, your security. So whether it's import, export controls, or ITAR, or even intellectual property, the ability to be able to secure that data and be able to share it with the right people at the right times. On top of that, you build these applications with the actual tools to help author the digital twin. So your mechanical CAD, your electrical systems, your software, your testing. And then finally, you have your overarching threads around program management and supplier management, verification management, so that you are in a process of continually managing all these processes and having access across the entire product life cycle. So when we look at Siemens and the industry's trust in Siemens, when you look at the top 10 countries in the world by revenues, one of the things that, looking at mechanical CAD, product lifecycle management, electrical system design and simulation, we see some of our competitors. We see, in mechanical design and CAD, but then what we really see is that Siemens has a strong position within all of these companies with respect to, many of these countries anyway, with respect to your mechanical CAD, where we're using, solutions such as MX, NX, our PLM system. Electrical system design is largely, all the major companies are using our solutions, as well as with simulation. And so we have a really nice cross section of companies that are using our solutions. Looking a little further and focusing primarily on the US and North America, what we see is, 100% of the national security launch vehicles use Team Center and NX. The submarines are being designed on the accelerator platform. Same thing with manned space programs. Interestingly enough, 95% of the world's commercial aircraft engines, the turbofan engines, and military, I should just say this is turbofan engines, are produced using NX and Team Center. So, the products that you really need to rely on when you're flying long distances, those are designed on Siemens products. And so we see this, airframe in the supersonic market, as well as many startups are now adopting accelerator portfolio to help them be successful. And then, I talked about the open, the being in the flexible and open ecosystem. And one of the things that we do particularly well is to be able to operate in these multi-CAD, multi-tool environments with our PLM solutions. And so we do a lot of we integrate a lot of CATIA models and manage a lot of that data in Team Center. And we have, across a lot of automotive and aerospace companies, we're managing multi-CAD, multi-tool, and this is just an example of that. So I mentioned, what some of our customers are doing, and one of the things that we really like, that we like to talk about, that we're proud of, is our success of our customers. And when you think about, that one, one of the earlier slides when I mentioned that, defense agencies are really seeking to reduce costs dramatically. They can't be on the current, the current curves, the current cost structures are no longer sustainable. And so what we saw with TX is the Air Force expected to pay almost $20 billion for this program. And Boeing developed this new trainer aircraft in less than 3 years, and they sold it to the Air Force for less than $10 billion. So less than 50% than what the Air Force expected. But the results that they had were dramatic. When they looked at, they talk a lot about model-based engineering, and what that led to is not only did it lead to first pass, they had fewer revisions of their engineering revisions, but they had a 75% increase in their first pass quality. But they were seeing, because they used the digital world to help assemble the airplane before they actually built their production line, that they were reducing things like splice times from 24 hours to 30 minutes, that their assembly times are going down by 80%. And they saw this dramatic improvement in quality, where they were seeing very little rework, very little scrap. When the parts came from the different suppliers, they fit together. And so this is a great example of a customer that's been very successful using the accelerator portfolio and the digital enterprise to really go faster and produce higher quality products. So I'm going to talk a little bit about engineering and some of the engineering solutions. I'm going to talk a little bit about manufacturing solutions. And this is just to this is really just to introduce you to the, to the topics and to really, lead into the future discussions. But when you're talking about engineering, how do you turn these highly integrated and complex products into a competitive advantage? Well, and I'll just use an example of urban air mobility, but there's some variation of this for any new product that's coming. So when you think about the challenges of urban air mobility, and you have all these electric motors, you have all these batteries, you've got to manage the power density. And where do you put all these batteries so that you have enough power to fly your air taxi for 30 minutes? You have electric propulsion, which is new technology. And because you have all these heat loads with the electricity, or with the electrical, with the batteries, you have thermal management. You have to understand how to manage the thermal loads on a structure, as well as dissipate that heat energy. You've got to be able to integrate all your systems together, including autonomous flight controls in many cases. And then you have to go through the verification and certification process. Some companies, like Lilium the other day, stated that it would take almost $1 billion to certify their air taxi. And so this is it's a very huge, big task, and you have to have a good plan in place, and you have to be able to manage this data so that it doesn't turn into $2 billion. And then you have to do all of this while providing a safe, comfortable, and reliable passenger experience. One of the key issues is systems engineering. And when you think about systems engineering and how does it connect to all of the other digital threads, the different design domains like design and engineering, the verification management, your program management, your manufacturing, you have these domains, but what's connecting them is your systems engineering digital thread, your MBSC digital thread, where you're taking requirements, your system models, your system safety, as well as your software and verification management. And this thread, what we actually see is it really intertwines with all of the other product domains. So the systems engineering, when you have the digital thread, you can use it to drive your program's technical scope. I always tell everybody, as a program manager, the the systems engineer was my best friend. If I understood the requirements in my system architecture, I knew the scope of my program. And if I had a good, strong verification management plan in place, then I knew what the finish line looked like. And it made it a lot easier to help manage my program because I had a good handle on the technical scope of the program. So this is the importance of systems engineering, not just as it drives into the design of the product, but as well as how you build it and how you work with your suppliers. Another issue, another benefit of the comprehensive digital twin is the ability to have this virtual integrated aircraft. So you bring all of your simulation models together into a single environment, what we call the virtual integrated aircraft. And the whole point of this is to be able to actually fly it before you build it. This gives you an opportunity to understand how the product operates, to find any issues that you would normally find during flight tests, that you hopefully are finding them here in the virtual integrated aircraft. So you can make design changes before you start committing to manufacturing. You are able to do this because you have this really rich, robust understanding of the performance that's contained within the comprehensive digital twin. And in the end, it really reduces the risk of your test programs because you've identified changes before you start testing, but it also helps your programs be a lot more effective because you're able to highlight the most critical areas, say, of your flight test envelope or your physical test envelope, so you can focus your energy on those parts of it, and it can really make you be a lot more effective. We have some customers that are reducing their test programs by 25 to almost 30% just through the use of the virtual integrated aircraft. And when we think about these test programs, it might take 18 to 24 months. If you can reduce that test program by 25%, that can be a pretty significant cost savings. We're also, with advances in the technology behind the engineering solutions, we're also seeing advances in the user interface, and where we're making moves into incorporating augmented reality and virtual reality. And so the benefit of this is obviously that you have this immersive 3D environment with high-end rendering. And what it enables is that your engineers are now starting to design in context. They're looking at the parts that they're designing much in the same way that the technician might be looking at it as he or she is building the product. And so they bring a different viewpoint now. And so you're able to take advantage of this to really look at different design alternatives, to design the products to be right the first time so that you don't discover those problems once you're out in the factory. And you're able to do virtual design reviews and reduce the need for these mock-ups. So we see this technology. This is just one aspect of technology, but we're also seeing more and more artificial intelligence and machine learning coming in to help automate some of these tasks. Some of these tasks that you don't really, allows your engineers to start focusing on solving the creative problems, but giving you more insight into the design and operation of your product. So moving on to manufacturing, the key here is when we talk about program execution excellence is how do you accelerate this production ramp up and really make sure that you can meet your quality targets while you're delivering these products faster. That's always a challenge for any manufacturing company. What I'm seeing, and I always like this story here, is this is an article that came out of Aviation Week. I should have had the credit on here, but this is a story about BAE and what they're doing with the UK's Tempest program, and what they're doing with the future fighter factory, and how they're using digital manufacturing. And I've talked to the director of manufacturing there several times, and they're using the tools to look at how do they use more automation, and how do they use additive manufacturing to really bring the cost of the airplane down. They recognize that if they're going to achieve their cost and schedule goals for the program, that they need to address it in the manufacturing area, and then use what they're developing in manufacturing to drive the requirements for the design. And it's in my opinion, it's a bit of a new paradigm. Having been in the engineering world for a long time, there's always a natural tendency to really focus on the performance and then try to understand how to build it later on. And sometimes the manufacturing voice maybe doesn't get heard as much, but the focus that they have is let's focus on digital manufacturing first. Use that to drive the engineering requirements that can then be incorporated into the overall design of the product. And some of these parts they're seeing, I saw one part that they were making where they're moving from it takes like literally 100 days to make this part, this large titanium frame. They're using additive manufacturing now to make it in about 2 weeks. So it's a pretty significant reduction in time. Well, with the production digital twin, it really does, it sets up a closed loop process. You start with your product design, with your bill of materials and your designs, and as well as your designing for quality. You move into your production planning and engineering phases so that you're developing your manufacturing bill of materials. In the middle here, that we'll talk a little bit more, you get into your design for manufacturing, your process validation, the simulation, and the virtual commissioning, which I'll talk about in a few minutes. You're doing your line design, your optimization, and you're checking this all out before you actually move into production execution. And then finally your model-based quality. And then as you move into your production environment, you start to bring in your execution systems. You're making sure that the as-built matches the as-designed, all your work instructions, and then you're taking those insights as you're going through your production processes to actually drive back into your product design as well as your production facility design, so that you have that continuous improvement that I mentioned on one of the earlier slides about the comprehensive digital twin. And so the role of the digital thread for intelligent manufacturing is, it's got a couple key elements, but really what you're trying to do here is you're trying to have a smarter integration upstream so that you can design and engineer your products better, but to have this seamless transfer of information as you go from your virtual product and your virtual production into your manufacturing quality operation. So you're orchestrating that information better, so you're having a seamless orchestration of your data as you move from engineering into manufacturing. And then you're able to contextualize the data with the manufacturing information that, so as you building the product, you're able to take that information and from the real product and then closing the loop to have that continuous improvements. Again, a slightly different view. But what this is doing is it's now starting to help extend your closed loop manufacturing quality and your sustainment of your products, to a little bit higher level. So you bring, the value of the PLM system and the digital thread is to help have more consistent data structures, to be able to, have your closed loop or your continuous optimization loops, as well as automating a lot of these data processes and providing feedback in a way that the upstream users can actually use it and take actions on it. So it's about enabling a closed loop manufacturing and closed loop quality process by having more access to the data as part of your overall manufacturing flow. One thing I wanted to highlight that's always kind of an interest is one of the solutions that we talk about around enterprise composites. In my experience, we're designing the composites and then we hand them off to the manufacturing line, and sometimes there's some disconnects and some breaks, and worse, our manufacturing teams are having to manually translate data into different systems. And so one of the things that we've really worked on is being able to take that product design and move into production planning as you move around this cycle, and then you go into your production execution and you bring in your automation, your automated tape layups, your laser scanners for the ply layups, your inspection systems, as well as bringing in the feedback from those analytics and closing the loop for that optimization. So again, this whole thought process around bringing the data and the insights back from the real product and having continuous improvement in not just your product design, but also your production designs. And so this is a high level view of what that looks like, but then we can bring capabilities. So within each one of those major tasks, there's a number of smaller tasks as you go through it, or capabilities that you need to have. So when you think about your production process around your just to highlight a few examples there, but you have your process validation, your composite part planning, your automation planning, your work instructions, all the information you need to start, to start planning your product. And then as you move into your production processes, to be able to manage the orders and all of the logistics, getting the material out of the freezer, doing your automated layup, going into your cure cycles. How do you schedule all those parts? For your cure cycles, that might take, some of them, some of the bigger parts might take 12 to 14 hours or longer. And so how do you schedule everything? Make sure that you can orchestrate that through the factories. So, we've been working, to be able to provide an end-to-end solution for you to help streamline the entire process, starting with engineering all the way through to your production line. A lot of focus on advanced manufacturing techniques, and a lot of companies are now looking more and more at automation and how do they connect their factory and use more flexible automation. I would say 10 years ago, or maybe 15 years ago, when we looked at automation, it was always perceived to be very costly, and it took time to implement. And I know I can say from my most recent experience a couple years ago, when we were looking at automation, we bought a robot, and it was actually a used robot, but we bought a robot and we were able to use the newer software out there to really check out all the automation. Probably within probably within about 2 months of having the robot actually installed on the floor and up and running, we were producing the first parts. And then we kind of figured out that, well, it didn't really take the robot that long to build the parts that we needed. And so it was like, okay, now what else is it going to build? And so then we started adding more and more parts to it. And pretty soon we were able to keep the robot pretty busy. So, full time. And it wasn't just building one part. So it's being a lot more flexible using the same equipment. So it was a little bit different viewpoint, but, really about, leveraging this advanced technology, using the intelligence of the digital twin for the programming, having it connected, and being much more flexible to changes in your work structure, and to really augment, your actual workforce, the rest of your workforce. I mentioned earlier, the comprehensive digital twin, the production digital twin, and how it relates to virtual commissioning. And I think this is, one of the key areas when you think about how much money you invest in tooling, in the line, the factory floor layout. You really want to be able to check everything out and make sure that it works before you start investing tens of millions of dollars in a new facility. And before you find this problem when you're in the middle of building your first parts, and then you end up with a production delay while you're trying to sort out that you had a clash with tooling, or you had a clash where the parts were brought together. And so the virtual commissioning, being able to use these high fidelity models of how your products are assembled, by using virtual commissioning with the rich, robust information available in the comprehensive digital twin, you can really avoid a lot of discoveries that you would have during the production process, at least of the first article. So a lot of companies that are using these manufacturing simulations are really seeing a lot of benefit in making sure that their production line works the first time. One other area that we're looking at a lot is the work instructions. How are you presenting the information to the technicians on the floor? And I'd say, I guess, I've talked to a lot of manufacturing managers over the last couple of years. It was like, I'd like to see the paper not on my shop floor anymore. And they started moving to tablets, and so they digitized the paper. But we're also seeing some movement where there was an effort to try to move some of this information into devices like Google Glasses. And some companies have had some success with that. And so what we're trying to do is be flexible, that, the technology on these devices is going to change pretty rapidly. But we want to think about how do we present that information so that technicians can use augmented reality to help check the part out, make sure that they have the right part, they can scan the part, and then that it's located properly by using some of these, using augmented reality as an aid to how to locate the parts, but to really start using the technology, the three-dimensional technology, to help the technician to be able to tailor those work instructions so that, if you have a new technician that's never done it before, maybe you need to give them the full set of the detailed work instructions. But if the technician this is the 100th time that he or she has done this work, well, maybe you can give them a reduced set of instructions where they can just check off the steps because they don't have to go through every single step. But then if you have a design change, maybe you need to present, more information to all the technicians so that you can help start to automate those processes based on the technician's work experience and actual and skill level. And I already mentioned the part verification and being able to automate some of these processes that I put the right part in and I put it in the right place, and it's automatically checked off. I don't have to go back in and close it out in another book or go out into another system to help automate some of those processes. And so this can really apply to a lot of different areas within the factory and into product support as you start, supporting, like MRO activities on an airplane. And then the last topic that I was just going to hit, I think is a fun topic, but it really talks to where we're going in the aerospace industry and additive manufacturing. We are doing a lot of work in this in additive manufacturing. It really is that it's leveraging the digital thread to the fullest. So you start with a three-dimensional part, you do your analysis, you do your light weighting to take the material out where you don't need to have it, and then you go through and you can build it, and then you can inspect it, and you can have this digital thread and traceability throughout the entire processes. I think it's going to change how we work. I mean, it's how we design planes. I'm used to, I've designed parts in a sheet metal and a machine shop environment and even composites over the years. And as you start to look at the parts that come out of these optimizations, that are not constrained by the limitations of a 5-axis machine, you can really get much more creative solutions. And I think you're going to see more and more additive as companies work through the regulatory challenges. You're going to see more and more additive manufacturing being used by these companies. Some of the regulatory challenges we'll be able to use and solve with simulation analysis because you're able to keep track of your process much better, and you'll be able to predict how the machine is going to produce the parts better, so that you can speed up some of that regulatory process. We're using machine learning now and some machine learning capability in our analysis tools, so that when you build parts, you can predict the allowables faster without, with fewer test samples and test coupons. And so we have some companies that are adopting that as well. So we are investing a lot in this. Siemens, not just the software division, but Siemens is investing a lot in additive and having that end-to-end process, really from the design all the way to the finished product. So I do think this is going to bring a lot of possibilities, and it's going to change how we build parts and maybe reduce the tooling that we need to have and give us a lot more flexibility. So in conclusion, really what we're trying to do with digital transformation and partnering with companies across the globe and within the aerospace industry is to help them innovate faster and really accelerate their product development. And how they're doing that is, they're getting their competitive advantage using digital transformation, using the comprehensive digital twin so that they understand their parts, their production processes, using very modern and adaptable solutions and making those easily available to our customers in a very flexible and open ecosystem. And I just want to say thank you very much, and we look forward to working with you. Thank you.
Thank you, Dale. Muchas gracias. In this moment, we start our Q&A session. We have very few time available, but if you want to state a question, you can actually do it en español or in English, Spanish or English, to our chat, and then we can translate to that. You were talking about the digital twins. One thing that comes around is that you mentioned that we have digital twins for products and processes and even situations. We're seeing digital twins like trade shows and things like that. Do you think this is going to lead us to have a digital twin of a person itself, or something like that? A digital twin of persons?
It's a little scary, but I do think possibly I would say yes. We've had some of our teams have actually modeled the lungs, and if you think back to some of the vaccine development that's happened with the COVID-19 vaccines, companies use our software to develop a digital twin of the vaccine, and so there was actually, so you're seeing this in parts of already where companies are, people are using digital twin technology to even develop like the most recent vaccines. So and I think they attribute a lot of that to the speed at which they were able to develop, because they were virtually testing it, and then as they were developing the vaccine. So yeah, it's a great question.
Don't you think that's a little bit scary?
And sometimes it's, I'd hate to think about the digital version of me walking around. But yeah, no, I think it's actually good, and I think it'll help us understand how to maybe cure cancer and some of these other diseases that we've dealt with for so long. So I think the possibilities are endless out there.
Yeah, it is so powerful that it's really that it's really scary.
Yeah.
But anyway, just to state the next steps for the digital transformation initiative that we have on the Innovation Commission that we have in FEMIA. You can look at out there. We put the link through the chat window as well, so you can check it out and everything. And we unfortunately we have some certain time restraints, and this is a very interesting and very moving subject. And I think if we start with the questions and answers now, we can be here for another hour easily. So I would certainly like to invite all of our attendees to basically send your questions over to us so that we can forward to Dale. And thank you very much. We certainly we're gonna switch to Spanish. Muchas gracias. Thank you, Dale, for this very interesting chat today. It was very it really you really leave us with our head spinning, at 1,000 RPMs. So thank you, and we'll certainly stay in touch. Como bien lo dijo Ricardo, estamos participando, estamos trabajando juntos en esta iniciativa de madurez digital y de transformación digital en la industria en México. Y pues bueno, seguiremos trabajando con Siemens y con todas las empresas de nuestro ecosistema aeroespacial. Bueno, también para recordarles nuevamente acerca del evento del sector aeroespacial más importante de Latinoamérica, que es FAMEX, se llevará a cabo del 22 al 25 de septiembre. No falten, tienen que estar ahí, es muy importante. Ahí están las ligas para conectarse y obtener un poquito más de información. Y bueno, sin más, solo les recordamos que les solicitamos, les pedimos encarecidamente que nos sigan en nuestras redes sociales, tanto en Facebook, Twitter, nuestro canal de YouTube y en LinkedIn, y por supuesto en nuestro correo electrónico de contacto. Y también recordarles de nuestro próximo evento, el próximo miércoles 4 de agosto, Sistemas de Observación de la Tierra, Nuevas Tecnologías y Aplicaciones. Ahí tienen el QR, pueden registrarse desde ahorita. Si tienen interés, háganlo, regístrense, no lo dejen pasar. Este es un tema también interesante. Ahorita lo mencionó Dale, que ¿cómo se llama? Que antes los temas espaciales eran reservados a las grandes compañías y a los grandes gobiernos, a los países con grandes presupuestos. Ahora esto se está democratizando y hay nuevos jugadores y hay muchas posibilidades. y prácticamente hay mucho que hacer en el espacio. Y bueno, sin más, yo no me queda más que desearles que tengan un muy lindo día, que pasen un bonito resto de semana y por favor manténganse sanos y nos vemos la próxima semana. Muchísimas gracias